Online Math Tutoring live stream, October 25th, 2021. Let's get it started. A construction crew has just built a new road. They built 43.75 kilometers of road at a rate of 7 kilometers per week. How many weeks did it take them? Okay, weeks. Let's list this out as an equation. So what do we got here? 7 kilometers per week times W weeks. We'll say let W equals weeks. Let W equal weeks equals 43.75. So the construction crew builds at an array of 7 kilometers per week. They go for W weeks. And after that, they get 43.75 kilometers. So to solve for W, we divide each side the equation by 7. So we got 7W divided by 7 equals 43. 75 divided by 7. Cancel the 7s, we get W equals 4375. I'm going to go off screen here real quick and just use my calculator. 6.25. W equals 6.25. So that's what we got. Nice and easy. Let's move it on up here. All right. Next one. 993 cold drinks bottles are to be placed in crates. Each crate can hold 9 bottles. How many crates would be needed and how many bottles will remain? All right. We have 9 bottles per crate. Let C equal the number of crates times C equals 993. So to simplify, we could say this, 9C equals 993. I'm going off screen here real quick. I'm going to just paste in our equation solver. Sorry, 9C equal to 993. Crates. I'm going to just paste this in here so you could see from our calculator. I want you to understand, though, that this requires one more step. You can't have fractional crates. Since we can't have fractional crates, we round up 1 to the next full crate. C equals 111. And the reason why is we have this leftover. What we'll do is just add another full crate and we can put the leftover in that crate, which means we need 111 crates. So this had a quotient equation, and that's how you solve that. All right. Let's do this one. Good old age word problems and algebraic expressions. All right, a man's age 10 years ago was 43. All right. So what this means is A years ago means we subtract A minus 10 equals 43. That's how we do that. But sometimes they may ask you to solve for A. If the problem asks you to solve for A, we type this equation into our math engine. Get A equal to 53. And I'm going to show you on off screen real quick. Use our solver. I'm just going to copy and paste this here for you. There we go. This is a one-step equation if they ask you to solve, so we just add 10 to each side to cancel out the 10s and isolate the a, and we get a equal to 53. So age 10 years ago is 43, which means the current age is 53. And that is that. All right, let's do this one. Stonemason builds 7 houses in 3 days. How many days does it take to build 11 houses? Let the build rate of houses per days is proportional. Set up a proportion of houses to days, where D is the number of days it takes to build 11 houses. So days to houses, 7 over 3, 7 houses over 3 days equals 11 houses over D days. Stonemason can build 7 houses in 3 days. We assume a proportional build rate. We want to know how many houses they can build or how many days it takes to build 11 houses. And I should have said that, yeah, houses to days. This is important because you want them houses to days on this side, houses to days on that side. All right. We can cross multiply. One off screen here just to show you. Cross multiply. And I'm going to grab the math. D equals 3 times 11 over 7. If you look at these fractions, we get 7D equals 11 times 3. 7D equals 33. All right, if we do the cross multiplication, divide each side of the equation by 7. It's 7D over 7 equals 33 over 7. D equals, I'm on the other screen. This is easier to do it that way. There you go. This means it's going to take 4.714 days to build 11 houses using a proportional build rate. You'll see a lot of these problems in pre-algebra and algebra, and they're always solved the same. If you can spot the language, you're going to have a huge advantage of saving time and figuring out these problems. All right, so let's do a variation problem next. F varies directly as G and inversely as R squared. The phrase varies directly or varies inversely means we have a constant K such that F equals kg over R squared. Now, let's pause here for a moment. First, I want to say varies directly. Actually, wait. We take a constant of variation called K, givens and assumptions. I had there, but I realize some of you have not had this before. Start at the beginning. Varies directly means we multiply variable term by K. And then we're going to copy this because I get the question a lot. What is the difference? We divide K by our variable term. Okay, now you have the necessary background to crush this problem. We've got our constant of variation K. F varies directly as G, so we multiply by G. But F varies inversely as R squared, so we divide by R squared. And this is our variation statement. So we had a variation, direct variation, and we also had an inverse variation. These are the two key terms here. And I'm going to italicize those because they're that important. All right, moving on. What else we got here? Good old temperature. One of these days, I'm going to build a shortcut for these. Midnight, the temperature was negative 15 degrees Fahrenheit. By the next morning, the temperature had gone up to 20 degrees. What was the temperature then? I actually looked this problem up online because it was confusing me. If it had gone up to 20 degrees, then that's your answer. But really what the student meant to say gone up 20 degrees. We start with negative 15. We add 20. We get 5 as our answer. Integers. What's happening here is negative 15 degrees Fahrenheit is our starting temperature at midnight. In the morning, the temperature shoots up 20 degrees. What is the temperature then? If you start with negative 15, you add 20, you're at positive 5, and that's how you get that answer. All right. Let's figure out what's going on with Leilani and her reading rate. Correct the spelling here, page. Capitalize. Okay. Leilani can read 20 pages in 2 minutes. If she can maintain this page, I think they mean rate, how many pages can she read in an hour? All right. We know that 1 hour is 60 minutes. If you don't know that, you can up time conversion. So every hour, 60 minutes. 20 pages per 2 minutes equals, declare some variables. Let P be the number of pages Leilani can read in 1 hour, which is 60 minutes. Right. The read rate is constant, so we can build a proportion. We assume Leilani reads the same rate, no matter what book, no matter what time of day. So if she can read 20 pages every 2 minutes, she reads P pages per 60 minutes, which is an hour. And if you remember earlier in the stream, we can cross multiply. Actually, I can't. Over 2 P over 60. I'm off screen here. 20 over 2 equals P over 60. All right. Let's just paste this in. We can cross multiply. And then solving for numerator 2, we get, this is divided by denominator 1. We just start with this. We're solving for numerator 2, right? Because simplifying, is that even spelled right? No, I got to fix that. Okay. So we get P equal 20 times 60 divided by 2. P equals 1200 divided by 2, and P equals 600. So what's happening is we have a proportional read rate, pages per minute. We want to know in 1 hour, which is 60 minutes, how much can Leilani read in pages? We can cross multiply. We solve for numerator 2 is what we want to solve for. Evaluate, simplify, and we get the answer of 600, which is great. So we had a proportion on this one. It's done. And if you're new to the stream or new to my channel, you'll find this link in many of our videos. You just go to mathcelebrity.com/community, and you can find all these problems that I'm typing out and saving here. They're also searchable on mathcelebrity.com, which is not our forum, but that's our main math engine. All right. Let's Keep moving here. All right, let's do this one. It's been lingering at the top, and I've been dodging it. A car, is traveling 75 kilometers per hour. How many meters does the car travel in 1 minute? All right, lot of trickery going on here. 75 kilometers per hour, but they want to know how many meters does the car travel in 1 minute. 1 hour equals 60 minutes. And then how many meters? So 1 kilometer equals 1,000 meters. So 1 kilometer equals 1,000 meters. Yes. 1 hour equals 60 minutes. We need to decide what time period. Well, we know the time period is a minute. So 75 kilometers equals 1,000 times 75,000 meters times 75 equals 75,000 meters. And the reason why is they ask how many meters does the car travel in a minute. 75,000 meters. Since 1 hour 60 minutes, the car travels 75,000 meters in 60 minutes. Now we've taken this and this, kilometers an hour, and we've converted it to meters and minutes because that's what the problem asks for. They want to know, the problem asks how many in 1 minute. So what we're going to do is we're going to divide 75,000 by 60, and we get 1,250 meters per minute, and that's our answer. So there was some trickery going on here. The problem reads to you in kilometers per hour, but they ask for meters per minute, so we needed to make 2 conversions. And I'll say convert from kilometers to meters, convert from hours to minutes. That's it. So this was a big one with conversions. I dodged it for too long. All right, let's go to this one. Each class can have 40 pupils. If a school opens 5 classes for grade 6, how many grade 6 pupils can it accept? Grade 6 pupils equal pupils per class times number of classes. Grade 6 pupils equal, we're told you can handle 40 pupils per class, and 5 classes equals 200 pupils. There we go. So this is a simple product. Nice and easy. I'm going to save that one for later. I got to do a little thinking in the back of my head here. Matthew works 45 hours at $22.10 per hour and 3 hours overtime and double time. Calculate his total earnings per week. All right. If Matthew gets 3 hours overtime, then his regular time is 45 minus 3 equals 42 hours. 3 hours overtime, 45 hours total worked. Calculate regular. We're going to do this in 2 parts, regular hours, overtime hours, and then we're going to add them both up. Regular hours earnings. All right. Regular hours earnings equal regular hour. Hourly rate times regular hours worked. So that is Matthew gets $22.10 per hour at a regular rate times 42. See what that is off camera. Quick. I already beat me with your calculator. 928.20. All right. 928.20. Now we want to calculate overtime hours earnings. And then we have hourly rate times 2 times overtime hours worked. Why do I say 2? Double time. Double time. Double time equals twice the regular hourly rate. Okay. And then 2 times hourly rate times overtime hours worked. Let's plug this in here. You get 22.10 is Matthew's regular rate times 2 because he's getting double time overtime times 3 hours overtime, right? And then I'm going off camera here to just pop this in. And he's got 132.60 overtime hours earning. Okay. Calculate total earnings. Total earnings equals regular hours earnings plus overtime hours earnings. You got 928.20 plus 132.60. Add those two together. Go off camera real quick. 1060.80. 60.80. And that's it. Anytime you see regular and overtime hours and they want to calculate earnings, you care about hours worked under regular, hours worked under overtime, and then the respective rates. You add those two values together and you get your answer. Moving on. All right. This is, I was laughing at this one because I've known the owner of Math is Fun, who's another site in our space for years now, and it was funny to see this. So Raphael's a software salesman. His base salary is $1,900, and he makes an additional $40 for every copy of Math is Fun he sells. They did not put the variable in here. Let P, I'm going to do P. Let P represent his pay in dollars. I'll just do C, represent the number of copies of Math is Fun he sells. Write an equation relating to. Then use this equation to find his total pay if he sells 22 copies of Math is Fun. The student typed this in, so there's missing information, which I'm filling in. I'm going to repaste this with my information filled in. We want a sales function or equation S of C, where C is the number of copies of Math is Fun. Actually, no, it's P. I'm sorry, it's P. So we got P equals price per sale times C copies plus base salary. It's important to know problems like these. There's always two parts. There's a fixed cost or a base, and there's a variable cost, which is there's a sale unit or some sort of unit times the number of units sold. P equals the price per sale we're told is 40 times C plus 1900. This is your first, this is a two-part question. That's your first one. Now we want to know total pay if C equals 22. P equals 40 times 22 plus 1900. P equals off camera here. 40 times 2, 880. 880 plus 1900. P equals 2780. All right. We did two things here. We built a sales function or an earnings function, and then we plugged in a value for C for that earnings function to get total pay. So this is earnings function. That's that. Right. Here's a little riddle. We get these little riddles once every while, and really a lot of these are just algebraic expressions. So I'm gonna do that here. You and your friend are playing a number guessing game. You ask your friend to think of a positive number, square the number, multiply the result by 2, and then add 3. If your friend's final answer is 53, what was the original number chosen? Let n be our original number. I'm just going to declare a variable for our, it could be O, it could be n, it could be x. It doesn't matter. I'll start with n for number. And then we're told it's positive, so there's a clue. Square the number. I'm going to take this in parts. It means we raise n to the power of 2. So we've got n squared. What I'm doing here is I'm going to build an expression off all this word salad here, and then we're going to find out how we get 53. Multiply the result by 2. So we've got 2n squared. We take n squared in the prior result, multiply it by 2. Got a new expression. So we've done square the number, we've done multiply the result by 2 now, and then add 3. 2n squared plus 3. All right. If the friend's final answer is 53, this means we set this equal to 3. Okay. Subtract. Now we want to solve for n. To solve for n, we subtract 3 from each side. Why? To isolate the n term. Paste this in. So we're going to systematically eliminate terms until we just get to n. And then we cancel the 3's. 3's on the left side. And we get 2n squared equals 53. Okay, positive number, square the number, multiply the result by 2, and then add 3. Divide each side of the equation by 2. Square divided by 2 equals 53 divided by 2. Cancel the 2's, we get n squared equal to, divide 53 by 2. Get 26.5, and then take the square root of 26.5. So n equals, we got plus minus square root 26.5. I'm going to take the square root of this. N equals plus minus this. Now, we are told the number is positive, so we discard the negative square root and get, it's just positive. We don't even need the sign, this number here. We go back up here, positive number, so we knew we could throw away the negative square root. We started with a number n or x, whatever we want to choose, squared it, multiplied the result by 2, and then we added 3. Oh, you know what? I just screwed this up. I'm sure you guys are screaming on the other end here. It's not 53, it's 50. No wonder this wasn't rounded. Oh, -5. I'm sure you guys are pounding the screen like, what are you doing? Take the square root of 25. There we go. So we got 5. Nice and easy. Square root. And then we also had an equation. And we had principal square root, which means the positive. All right. So that was that. Thanks for bearing with me. 2 more and then we'll shut it down for the day. Sum of a number and twice its reciprocal is 3. The phrase a number means an arbitrary variable. Let's call it x. X. You can choose anything for this, by the way. I just like to choose x because it's common. The reciprocal of a number means we take 1 over that number. We have 1 over x. When it says it's reciprocal, that means we take 1 over whatever it was, which is x. Twice the reciprocal means you multiply 1 over x by 2. So we have 2 over x. And then we're going to do this part. So as you could see, if you haven't figured out in these videos, I like to take first principles step by step, break it into easiest parts to simplify, and then go from there. The sum means we add. So we have x plus 2 over x, the sum of a number, which was this, and twice its reciprocal, which is this. The sum means we add. All right, we are almost there. The word is means equal to. So we set x. Sorry, I'm just going to paste this in. This equal to 3. All right. Here is our algebraic expression. All right. Last one for the day. Dion opened his account starting with $650, and he is going to take out $40 per month. Mai opened up her account with a starting amount of $850 and is going to take out $65 per month. When would the two accounts have the same amount of money? I'm just checking chat here real quick. All right, we're good. Going back. We set up a balance equation B of M, where M is the number of months. Set up Dion's balance equation. We've got B of M equals starting balance. I'm sorry. Starting balance minus withdrawal amount times M for months. Why do I subtract? Because withdrawals, in fact, I should do this. Withdrawals mean we subtract from our current balance. I'll put it here because each balance is going to be different. Starting balance minus withdrawal amount times M. B of M equals Dion starts with 650, right? And he takes out $40 a month. So his balance decreases by this. This is what you get for the balance with the $40 withdrawal. All right. Now we're going to do the same thing for Mai. Mai is also withdrawing. The word take out is also withdraw. She takes out 65 and she starts with 850. So this is Mai's balance equation. We have both balance equations, which is great. Now the problem asks, when would the two accounts have the same amount of money? When the two accounts have the same amount of money, we can set both balance equations equal to each other. This equal to this. And solve for m. So we set Dion's balance equation equal to Mai's balance equation because that's what the problem asks for. I'm off screen here on the Math Celebrity main site, so I could solve for this, and you guys could see. Hold on, my screen's frozen. There we go. All right. Instead of having to type all this out, you could just see it. Okay. We were here, and I just pasted in the Math Celebrity calculation for m. So I'm going to let you read through this here. And what we're doing in step 1 is just grouping the variables. So we're adding 65m to both sides. That way we can isolate m on one side and the numbers on the other. We get this. Next, we want to group the constants. So we subtract 650 from each side. And we get this. And finally, and I'm going to clean this up because the paste from the main site is thrown off with table designs. Got this. Got this. Your final answer is m equal to 8. So at the 8th month, both balance equations will equal each other, and that is your answer. So we've got balance equation. That's it. So I want to thank you for watching the stream, and I